In this demonstration of the importance of fluid pressure, I've brought from home an ice hockey or air hockey game, maybe familiar to many of you, and seemed particularly appropriate for a demonstration in Minnesota. We have a puck here that I've added a little bit of extra weight to in terms of a Lincoln penny. And what I'm going to do is to illustrate to you that you can slide the puck across the surface, and if I don't have the air flowing beneath, my fluid pressure being air, my fluid being air, and the pressure of the air being forced up through these small holes in the surface, that without the fan on, it takes a fair amount of, now, not too much force, but a bit of force to make the puck slide across the surface. But by simply injecting a little bit of air beneath, my fluid beneath the puck and the surface on which I'm sliding the puck, I can make sliding the puck much more easily. And so this is meant to be kind of a very rough or crude analogy to what might happen, for example, along the San Andreas Fault, where a little bit of fluid between the two surfaces of the fault makes sliding along those surfaces much easier. And again, it's really one of the observations that has been used to argue that there must be fluid pressure in the San Andreas Fault, is the fact that there's very little heat production when the fault slides. And if you had two rough rock surfaces sliding past each other, you'd expect to generate a fair amount of heat. But if there's fluid holding them apart, you could slide those surfaces much more easily without the generation of heat.